Okay, in 3.3c, we're finally going to do it. I'm going to show you how you can get rid of fractions or decimals. So I do want to point out that recall that you can still deal with the fractions, the decimals. Every problem that we've done so far using fractions and decimals, we just dealt with them. Okay, so we have got another option. So recall our steps in solving a linear equation. In that first step, that I can just call briefly the cleanup of each side, if there are fractions or decimals, you can clear them. And you clear them by multiplying, by multiplying both sides by the LCD. And you'll see shortly what that means before we get that variable naked. Okay, the great thing, the wonderful thing about equations is that you've got two sides, and you can do anything you want to do as long as you do it to both sides. So having an equation gives us lots of freedom because we've got two sides. So remember that changes in math come in pairs, so the sides give us a pair to work with. Okay, so I just want to point out to remember the difference between an expression and an equation. So these look a lot alike, right? But over on the right, I see an equal sign. So, let's get rid of that. I see an equal sign, and I'm going to put it in red because that changes everything. When we have an equal sign, we can do anything we want as long as we do it to both sides. So that allows us to get rid of or clear fractions. And we're going to start with fractions first, and then we'll take a look at decimals. And if you think it's nice to clear fractions, it's even easier to clear the decimals. So now contrast an equation where you have two sides to an expression. So this is an expression. It looks exactly the same, but there's no equal sign. There are not two sides. So in this case, you just have to deal with the fractions. You cannot get rid of them. Okay, so I want to emphasize that we love equations because we can do anything we want, and with expressions we just have to do what it tells us to do. Okay, let's take a look again. We're just going to take a look at fractions first. Notice something here. If we take 8 times 1/2, 8 times 3/4, and 8 times 3/8, let's see if anything nice happens here. So we can recall that we can put this over 1, and these is going to cancel, so we will end up with 4. Again, when we take 8 times 3/4, the top and the bottom will cancel, and we're left with 6 over 1, or just 6. And then the last one, these cancel, and we're left with 3. So that's kind of nice, right? Let me get rid of the mess I made here. Oh, I didn't want to get rid of that. Okay, let me recreate this. This was a 4, and this was an 8. So when we multiply this whole number times these fractions here, we ended up with whole numbers, and we like working with those nice, sweet whole numbers. Okay, do you notice we multiplied everybody by 8 and something magical happened? So let's take a look at the fractions that it happened with. We had 1/2, 3/4, and 3/8. So I look at these fractions and notice, oh, look at the denominators, 2, 4, and 8. What does 8 that we multiplied by here have to do with our denominators 2, 4, and 8? Oh, the LCD of our denominators 2, 4, and 8 is 8. And that was a magic number because when we multiply all those fractions by 8 by the LCD, we end up with nice numbers. Let's take a look at that a little bit more here. So I'm going to ask you to multiply these out. So 12 times 1/2, 12 times 2/3, times 3/4, times 5/6, and times 11/12. Okay, so let me help you with that. And we're going to do it a little bit more slowly here, and I'm going to do this bottom, and I'll do my work in blue. 12 times 1/2. Well, 12 is the same thing as 12 over 1, and I'll use my red pen to cancel. Divide by 2. divide by 2, and we get that. Result is 6 times 1 is 6, and downstairs we have 1, and anything over 1 is just itself. So we end up with 6, a nice number. Next one, let's take a look at what happens when we multiply 12. Let's do this in blue. Okay, so checking my time, we're in blue here. 12 times 2/3, throw that 12 over 1, we can cancel, divide by 3, and we end up with 8 over 1, which is just equal to 8. Oh, I love it. So we can put that in there. We get an 8 here. Okay, so let's do a little bit more. What happens when we have 12 times 3/4? Throw that over 1. We can cancel, divide by 4, we end up with 9. So we've got, okay, 9, another nice number. Next one, 12 times 5/6. 12. Let's just keep this in blue. Okay, 12 times 5/6. Do you notice that this bottom denominator here, we can always divide by that number. Divide by 6, and we end up with 10. Okay, so we got a 10 there, and let's just do the last one. 12 times 11 over 12, throw that over 1, and like every time, that 12 can be divided by 12, 1, the 12 here can be divided by 1, and we end up with 11. So taking all of these fractions and multiplying them by 12 gave us nice numbers as our answers. So let's take a look one more time at the denominators we had and the number that we multiplied it by. Our denominators are, the first one is 2, 3, 4, 6, and 12. And when we multiplied by 12, we got nice numbers. And do you notice the LCD of these numbers, the smallest number that they all go into, is 12. So the moral of the story is, let's get this up here. Okay. To clear fractions, multiply both sides, because we can do that with equations, multiply both sides by LCD of all the denominators that you see. And goodbye fractions. Okay, we will start to do some examples in the next video. I will see you then.